Section 8.6 is on solving rational equations and inequalities. A rational equation is an equation that contains one or more rational expressions. So it's basically going to be an equation. It's going to have an equal sign in it. It's going to have rational expressions with x's, and we need to figure out what x is. So to solve, we're going to multiply the entire equation by the least common denominator. This will eliminate the denominator and just leave us with an algebraic equation that we can solve. So here's our first example. We need to solve and check this. So I have 7 over 12 plus 9 over x minus 4 equals 55 over 48. So looking at this, my common denominator is going to be, well, if it just were 12 and 48, it would be a 48, so that needs to be a part of it, and an x minus 4. So what I need to do is multiply the whole equation by that common denominator. And since we're dealing with fractions, if you'd like to put it over 1, you can do that. And think of distributing 48 times x minus 4 3 times. So when I do 48 times x minus 4 times 7 over 12, the 12 and the 48 will cancel, leaving me with the 7 that I originally had. Those will cancel and give me a 4, and then the x minus 4 stays there. So 48 times x minus 4 times 7 over 12, the 12 and the 48 cancel, leaving me with the 4, the original 7, and the x minus 4. And my denominator's gone. Now, multiplying 48 times x minus 4 times 9 over x minus 4, I'll have the 9. My x minus 4's cancel, and that leaves me with a 48. And then doing my last distribution, my 48s will cancel, and that leaves me with 55 times x minus 4. And now it looks a lot better. It's still a little sloppy looking, but it's a lot better than it was before because there's no fractions. So 7 times 4 times x minus 4 is going to give me 28x minus 112, plus 9 times 48 is 432, and that equals 55x minus 220. Yes, they're big numbers, but it's not that bad. So simplifying that and moving things around, subtracting 55x from each side is going to give me a negative 27x equals, and then moving these over here, a negative 540, and then dividing both sides by negative 27, x is equal to 20. Okay. Before I box that, I should try to check that and see if that works. So when I plug x in there, plug x back into the original equation, I'm going to have 7 over 12 plus 9 over 20 minus 4 is 16. Is that equal to 55 over 48? And actually, I would just do the addition of those fractions in the calculator, and indeed it does check. So my answer is x equals 20. Here's a second example. 7x over 3x plus 3 minus 5 over 4x minus 4 equals 3 over 2x plus 2. What I'm going to do is factor each of my denominators. So this factors into 3 times x plus 1. This factors into a 4 times x minus 1. And this factors into a 2 times x plus 1. Maybe I'll just cross those out so they don't get in the way there. Okay, so my common denominator, I have a 3, a 4, and a 2. So I'm going to have a 12 as part of my common denominator. And I'm going to have an x plus 1 and an x minus 1. Okay, so multiplying each fraction by, I don't know, where am I going to put it here, 12, x plus 1, x minus 1, basically over 1, and that's going to cancel all of my denominators. Okay, so originally I have here a 7x, that's going to stay there, but then when I multiply my common denominator times the first fraction, the 3 and the 12 will cancel and leave me with a 4 on top. The x plus 1's cancel and leave me with an x minus 1. Minus 5, which was originally there, My 4 and my 12 will cancel and leave me with a 3. My x minus 1s will cancel and leave me with an x plus 1. And I think that's it. And then I originally have the 3 that needs to stay there. The 2 and the 12 will cancel and give me a 6. And the x plus 1s will cancel, and that'll leave me with an x minus 1. Oh, you know what? I think I have the problem written wrong. I think I originally wanted an x there. Sorry about that. It needs to be a 3x there. Okay? Alright, so let's clean that up a little bit. So multiplying all of this out is going to give me a 28x squared minus 28x. And this is going to give me a negative 15x minus 15. And this is going to give me an 18x squared minus 18x. Okay? What I'm noticing is that I have x squareds. They're not going to cancel each other out. This is a quadratic, so I need to make it equal 0. So moving everything to this side, I will end up with 10x squared minus 25x minus 15 equals 0. That is factorable. Oh, and actually, I think what I'll do is I'll divide everything by 5 to give me a 2x squared minus 5x minus 3 equals 0. That is factorable. That factors into 2x plus 1 and an x minus 3. So x is equal to a negative 1/2, or x equals 3. And unfortunately, we actually have to check those. You would check them by plugging each one back into here. Definitely use your calculator, but both do work. And we have both of those as our answers. One thing that you do want to look for is go back to your denominators and notice what x definitely cannot be. X cannot be a negative 1, it would make this 0, and x cannot be a positive 1, it would make that 0. And let's take a look at our last example here. I have 2x plus 1 over x squared plus 2x minus 8 plus 2 over x plus 4, and that's equal to 1 over x minus 2. So let's go ahead and factor this guy here. That's going to factor into an x plus 4 and an x minus 2. X plus 4 is already factored, x minus 2 is already factored, and I'm really liking this. So my common denominator is going to be an x plus 4 and an x minus 2. That's very nice. So multiplying the whole thing by that, and distributing 3 times is going to eliminate our denominators. And in fact, these two will cancel with those two, leaving me just with an x plus 1. And then I'll have plus 2 for my second fraction. The x plus 4s are going to cancel, so I'll have it times an x minus 2 equals, my x minus 2s will cancel, x plus 4. And I'm liking the looks of this because I'm not seeing any quadratics. So this is going to simplify into 2x plus 1 plus 2x minus 4 equals x plus 4. Simplifying that, 4x minus 3 equals x plus 4. 3x equals 7, or x equals 7/3. Just a quick look at what x cannot equal. X can't be a negative 4, x can't be a positive 2, no problem. And if you were to use your calculator and plug this back in, you will find that this does indeed check. So to solve rational equations, we really didn't focus on rational inequalities in this video, but to solve a rational equation, figure out what the least common denominator is and multiply each part of the equation by that common denominator. That will eliminate your denominators, they'll cancel out, and you'll end up with a simpler algebraic expression to solve.